All right, hello. Um, let's start this lesson off by talking about percentiles. Now, percentiles is the 11th topic that we're going to be covering in statistics. And the objective for the lesson is to determine the proportion or percentage of the sample above or below a given value from raw data, frequency table, or cumulative frequency curve, right? Now, we discussed percentiles when we were learning how to determine the quartiles. But in this lesson, we will use the percentiles to solve some problems so we know how to determine the proportion or percentage that we're interested in. All right. In the next slide, you'll see why this is important. This is important because imagine that you are applying for something, some kind of student program, and they say that they're only accepting the top 10% of students. How do you calculate to know if you're in the top 10%? And similarly, companies, well, if you're in the top 10%, there's a certain amount of people that they're going to take from the candidates, right? Similarly, companies may use percentiles to rank the earnings of their employees to pay bonuses. So when you understand this, you would be better able to make decisions such as in fields of academics or careers or even in finance. The first thing we're going to start off by doing is looking at an example. The example is one that students tend to come across, which is dealing with raw data of exam scores. A student is awarded a math scholarship, a school is awarding math scholarships to students, and they want the top 25% grade, the students with the top 25% of the grades to be able to get in for these scholarships. So the questions are listed as follows. What proportion of students score below, what portion of students score below 70, right? To do this, all we have to do is just identify how many of them is below 70. So we're seeing here, this is below 70, this below 70, below, and this here is below. Now, we're not looking at 70 because they want only those below 70, right? So 70 and above is good. Below 70, not good. Okay, so we have 1, 2, 3. We have 1, 2, 3, 4, 5, 6. So since we have 6, then what we have to do is just simply take that 6 divided by the total, which is 12, and we see that that is a half. And right away we can see that a half, the proportion is 1/2 of the students, right? A half of the students score below 70. And then they ask what percentage of students scored above 80. Okay, so for the percentage of students that scored above 80, I'll just change the color of my pen here. For students above 80, we have 1, 2, 3, 4. Right, so we have 4 students above 80. And if we have 4 students above 80, and we have 12 students total, we multiply by 100%, and then we cancel off everything. So 4 into this 1, 4 into this is 3. 1/3 of this is 33 and a third percent. Let me write that better. Right, 33 and a third percent. Okay, and then what is the minimum score required to be in the top 25%? So top 25% means we're looking at only 25% of these students. If we're looking at 25% of these students, then we're looking at 25 over 100 multiplied by 12%, right? This is a quarter, and yeah, I know the percentage in the wrong place, but let's take this, okay. A quarter of 12 is 3, and we're looking at 3 students, right? We're looking at the top 3. Okay, so if we're looking at the top 3 students, we're looking at the 3 highest. So we're going to just simply arrange your values, arrange these values here in ascending order, and you'll be able to get. Or you can just start with descending order and just take the first 3. So let me just start with descending order. Actually, that makes it much faster. Okay, so we're seeing 95, that's the highest, and then we have 90, and then the next one will be 84, right? So the minimum score that you would require to get into the top 3 would be 84%. Sorry, 84. Whatever the graded system is, marks or percentage, whatever. The score you need is 84 to be able to qualify to be in the top 3, right? Let's go on to the next one. A company is offering bonuses to employees earning the top 20%, and they want you to use the table on the left to answer the following questions. What proportion of employees earn 50,000 TT? So we're looking at the ranges. We're seeing right up to here is here we have 50,000 to there, but we know that because of its range, we'll ideally take this point here, right? So what proportion of employees earn below 50,000? So this is, here is 50,000, here is below 50,000. So we're taking this value, and this value. So we have 10 plus 8 plus 5, so that is 18 plus 5 is 23, right? So the proportion is 23 out of the total. So we know that the total is just simply going to take this and this, that's 20, 30, 40, so 23 out of 40, right? That's the proportion of employees who earn below 50,000. And then they say, what percentage of employees earn more than 60,000? So 60,000 is here, that's this here, which is 5 out of the 40. So if it's 5 out of the 40, multiply by 100%, and we'll take 5 into this 1, 5 into this 8, and 4 into this is 2, 4 into this is 25, and we get 12.5%, right? And I think we have one more here. What salary range qualifies for the top 20% bonus? So we want 20% of 40 total. So we're saying 20% of the 40. Sorry, that's written wrong. 20% of 40, which is the top 8. Right, we're looking at the top 8. So when we look back at the table, we're seeing 5 here, and this added here will be 17. Right, so these two here will be 17. So the top 8 is going to fall right in these two ranges, and therefore this is the range you're looking for. This is the minimum range that you're looking at. So the 58,000 to 59,999. So the range you're looking for is here. Right. Let's look at this one here, sports performance data. National Athletic Committee is selecting runners for an elite training program. The top 15% of runners will be invited to the program. The race times in seconds for 20 athletes are as follows. And the questions are, what proportion of runners completed the race in under 50 seconds? Okay, let's see, under 50 seconds. So we're looking at anything in the 40s. So 1, 2, 3, and this is 4, 5, this is 6, this is 7, this is 8, and this is 9, right? So 9 out of the 20 athletes, that's the proportion that we have here. 9 out of the 20 athletes scored under 50 seconds. What percentage of runners took more than 52 seconds? All right, let's look at changing the color here now. 52 seconds we're interested in. So this is 1, 2, 3, and then 4. So we have 4 out of the 20. So what percentage? 4 out of 20 multiplied by 100. 5, so it is 20%. Right, so the 20% of the runners took more than 52 seconds. Right, and yeah, that's it. And what is the maximum qualifying time for top 15% of runners? Well, first let's find 15% of 40, right, which is 15 over 100. 100 times 40. there, 5 into this 3, 5 into this 2, 2 into this 1, 2 into this 2, and 3 into this 6. So we're looking at 6 of erasers. And we're looking for the smallest time to the largest time, right? Looking for the smallest time to the largest time because we're not interested in people who are slower than that. We're looking at just simply the 6 people who were finishing the race in the fastest. And I should not have done that because then I could have I would have been able to get just an isolated few, and I erased it. Okay, so let's see, 48.2, 47.8, 49.7, and let's see, 48.9, 49.5, and 49.3, and let's see, 47.5. Oh well, 47.5 means that I can cancel out this 47.5 and 48.5. 48.5 means that I can cancel out this. Okay, 48.5 and 49 means that I can cancel off this here. So 49. Right? So the scores that I'm going to get are 47.5, 48.2, 48.5, 48.9, 49.0, and 49.3. Those are the top 6 runners. So the maximum time you're allowed, anything under that time is qualified. So 49.3 is your max time. That's the max time you're allowed to be able to qualify. Right, so that's how you'd use percentiles to solve some problems. Okay, in this lesson, this blank slide here is just to do working on, which I didn't use. Right, so in this lesson, we learn how to determine the proportion or percentage of a sample, and we do that by using different sources, which is raw data, frequency table, and cumulative frequency. Right, so thanks for joining the lesson. I know it was a very boring kind of lesson. If you find the content if you find the content useful, please let me know. If you don't, then thanks for watching, however long you decide to watch for. I'll see you in the next lesson.